Dear students, in previous lecture we have done with the test of significance and all, right. Now let us move to the degrees of freedom and student P distribution. Okay. Now degrees of freedom. Degrees of freedom means what? Suppose there are n number of observation, then 1 less than n, that is n minus 1, we can call it as its degree of freedom. That is, it is the number of values in a set which may be set arbitrarily. Suppose the degree of freedom of 5 observation is, suppose n equal to 5, then its degree of freedom is 4. Similarly, for 7 observations, degree of freedom is 6, like that. So degrees of freedom equal to n minus 1 for n number of observations. Similarly, it is n minus 2 for n minus 1 number of observations. Similarly, n minus 3 for n minus 2 number of observations, right? Now here we are using two different tests, very important test, that is student T distribution and another one is chi-square test. So both are very important for solving the problem under population mean and all. Now it is to test the significance of a sample mean for a normal population where the population S is not known. So when the population capital S is not known, then we are using this. Okay, it is denoted by what? T. T equal to x bar minus mu divided by S into root n. Here n represent what? Sample size. X bar represent what? Population mean. Mu represent what? Normally mean, right? Okay. Now x bar is nothing but mean. Mu is nothing but population mean here. X bar is mean here and mu is nothing but population mean. What is S square? That is 1 by n minus 1 into summation x minus x bar whole square. We want its square root to simplify T formula, that is T equal to x bar minus v by s into root n. But S square is nothing but 1 by n minus 1 into summation x minus x bar whole square. Here we need to test the hypothesis whether the sample mean x bar differs significantly from the population mean. Okay, this is sample mean and this is population mean. Now if the calculated value of T is greater than the table value of T, that is T of 0.05, or again here 5% level of significance and 1% level of significance. Suppose the value is exceeds the given table value, then we say that the difference between x bar and mu is significant at 5% level of significance. Similarly, if T is greater than T 0.01, the difference is significant at 1% level of significance. Okay. Now here we need to check for table value of student T distribution. Okay. Now first problem, a machine is expected to produce nails of length 3 inches. A random sample of 25 nails gave an average length of 3.1 inches with the standard deviation 0.3. Can it be said that the machine is producing nails as per the specification? The value of students' T distribution is 0.05 for 24 degrees of freedom is 2.064. Here n equal to how much? 25. So what is its degree of freedom? 1 less, that is 24 is the degree of freedom, right? Now what is given here? Mu equal to given 3 and here mu equal to what? See, expected to produce. Expected to means in here expectation means mean. So mu equal to 3 and here what is given here? X bar equal to population mean given, that is 3.1 and n equal to 25 and what is standard deviation? Yes, given already ready here. So S equal to 0.3. Just we need to apply the formula for student T distribution. What is T here? T equal to x bar minus mu by S into root n. Use that 33 here 3.1 minus 3 divided by 0.3 into root 25, that means into 5. Simplify, you will get 1.67 and you have to check the value whether it is greater than the limit or less than the limit. Here actually for the student T distribution they have given value already what for 24 degrees of freedom, t 0.05 they have given 2.064. So obviously it does not cross the limit. Therefore the hypothesis that the machine is producing nails as per specification is what? Accepted at 5% level of significance, because it is less than the given limit. Okay. Now next, find the student's t for the following variable values in a sample of 8, that is minus 4, minus 2, minus 2, 0, 2, 2, 3, 3. Taking the mean of the universe to be 0. See what universe mu equal to what? 0. So mu equal to 0, and n how much? Sample size 1, 2, 3, 4, 5, 6, 7, 8. So n equal to 8. So what is x bar? Because here x bar is not given, we need to find x bar equal to what? Sum of each x divided by n. So minus 4 minus 2 minus 2 plus 0 plus 2 plus 2 plus 3 plus 3 divided by 8. That is what? 1 by 4, that is nothing but 0.25. What is s square? We need to find what? Variance. S square is nothing but what? 1 by n minus 1 into summation xi minus x bar whole square. That is 1 by 8 minus 1, that is 7, into what? Xi minus x bar whole square, that is minus 4 minus 0.25 whole square, that is minus 4.25, minus 2 minus 0.25, that is minus 2.25 whole square, like that. So each and every summation you have to find here sum of the terms. You will get what? 49.5 you will get divided by 7, that is 7.07. So s square is 7.07. So what is s? That is square root of 7.07, that is 2.66. Now substitute it in the student t distribution formula, that is x bar minus mu by s into root n. X bar is what? 0.25. Mu is what? 0. What is n? 8. And what is s? That is 2.66. Now simplify, you will get 0.266. Here they asked just to find the t value, that's it. And they have not asked about accepted or rejected. In that case you just need to calculate the t value, that's it. Okay. Now 10 individuals are chosen at random from a population, and their heights in inches are found to be what? 63, 63, 66, 67, 68, 69, 70, 70, 71, 71. Test the hypothesis that the mean height of the universe is 66 inches, and they have given already t 0.05 equal to what? 2.262 for 9 degrees of freedom. That means 10 individuals means n equal to 10. So degrees of freedom is obviously 9, and its value already given. And what they given here? Any mean value given? Yes, here universe mean value of universe is what? 66, that is mu equal to 66. Now x bar is unknown. How to find x bar? Add this 63 plus 63 plus 66 plus 67 plus 68 plus 69 plus 70 plus 70 plus 71 plus 71 whole divided by 10, that is 678 by 10, that is 67.8. Now we got now x bar, we got a mu, we got n. Now what is s here? That is we need to find standard deviation. Before that we need to find what? Variance, s square. Formula for s square is nothing but 1 by n minus 1 into x minus x bar whole square. So that is 1 by 9 into x minus x bar whole square is what? 63 minus 67.8 whole square plus again 63 minus 67.8 whole square plus 66 minus 67.8 whole square plus 68 minus 67.8 whole square plus 69 minus 67.8 whole square plus 70 minus 67.8 whole square again plus 70 minus 67.8 whole square again 71 minus 67.8 whole square again plus 71 minus 67.8 whole square, like that you need to calculate. Then what you will get here, that is s square equal to 9.067. So what is s square root of this value? That is 3.011, right? After computing s value, just replace it in the t expression. What is meant by t? X bar minus mu by s into root n, that is 67.8 minus 66 divided by 3.011 into root 10, that is 1.89, which is less than what? 2.262. Obviously it is given value is less than the given limit. Therefore the hypothesis is accepted at what? 5% level of significance, right? Now let us move to the next problem. A certain stimulus administered to each of the 12 patients resulted in the following change in the blood pressure, that is 5 2 8 minus 1 3 0 6 minus 2 1 5 0 4. Can it be concluded that the stimulus will increase the blood pressure? But given here student T distribution for 11 degrees of freedom under 5% level of significance, that is T 0.05 for 11 degrees of freedom is what? 2.201 given. What is X bar here? Find out. That is 5 plus 2 plus 8 minus 1 plus 3 plus 0 plus 6 minus 2 plus 1 plus 5 plus 0 plus 4 divided by n. N means number of observation here 12. So 31 by 12 it gives us 2.5833. What is S square? Find out S square, that is 1 by n minus 1 into xi minus x bar whole square summation. Now that is nothing but 5 minus 2.5833 whole square, again plus 2 minus 2.5833 whole square plus and so on, divided by n minus 1 means 11. So what you will get here? Finally 9.538, that is S square value is 9.538. So what is the square root of this? S equal to 3.088. Now obtain t value here. Now since here mean not given, obviously how to assume it as 0. Okay, so t equal to x bar minus mu by s into root n. So let us suppose that the stimulus administration is not accompanied with the increase in blood pressure. Therefore we have to take mu equal to 0. So 2.5833 minus 0 by 3.088 into root n. N is 12, so root n is root 12. Simplify, you will get 2.8979. That means approximately equal to 2.9. But it exceeds the limit 2.201 because they have given already under 5% level of significance. Student T distribution value is this much they have given. So hence the hypothesis is what? Rejected at 5% level of significance, right? So we can conclude that with the 95% confidence that the stimulus in general is accompanied with the increase in blood pressure, right? Now let us move to the next sum related to this. See here. A group of boys and girls were given an intelligence test. The mean score, standard deviation score, and numbers in each group are as follows. Now what is given here? Men, here boys and girls given. Here now mean, standard deviation and n given, right? Now here boys, how much? Mean is 74 and for girls 70. Standard deviation is 80 for boys. It is 10 for girls and n equal to 12 and n equal to 10 girls. Now is the difference, the means of the two groups significant at 5% level of significance? But when t 0.05 equal to 2.086 for 20 degrees of freedom. Okay. Now here say we have what is given, x bar given, s1 given, n1 given, and y bar given, s2 given, n2 given. There are two different cases, right? So what we have to do? We have to calculate it for here difference between these two. So x bar minus y bar divided by s into, this is the formula to compute when two different data is given. So they have given already x bar mean, s1 means standard deviation, n1 means number of observation for boys. Similarly, y bar represent mean for girls, s2 represent standard deviation for girls, and n2 represent again number of girls, right? So what is t here in this case? Since there are two different data, we have to take x bar minus y bar divided by what? S into root 1 by n1 plus 1 by n2. Simplify this, what you will get? Now before that, what is S? How to find S? Before finding S, you need to find S square. What is S square for two different data? That is standard deviation for two different data, variance for two different data is what? N1 S1 square plus N2 S2 square divided by N1 plus N2 minus 2. Okay. and it is already given n1 is ready 12, s1 square, s1 is given what here, see here 8. So what you can apply directly, 8 square. Similarly, plus n2 is nothing but 10. S2 square means 10 whole square divided by n1 plus n2 minus 2. N1 is 12, 12 plus 10. So 22. 22 minus 2, that is 20. So you can find easily 1768 by 20, that is equal to 88.4, or S equal to what square root of this, that is 9.402 or 9.4. So what is t value? X bar minus y bar, that is 74 minus 70 divided by what? S into root 1 by n1 plus 1 by n2. Simplify, 9.4 into root 1 by 12 plus 1 by 10, which is equal to 0.994. So t value equal to 0.994, but it is less than the given limit 2.086. Thus the hypothesis that there is difference between the mean of the two groups is accepted at 5% level of significance, right? Now, next, a sample of 11 rats from a central population had an average blood viscosity of 3.92 with a standard deviation of 0.61. On the basis of this sample, established 95% fiducial limit for mu, the mean blood viscosity of the central population, that is they have given t 0.05 equal to 2.228 for 10 degrees of freedom. So n equal to how much? 11, right? And x bar what is given? Mean here, average or mean or expectation, population mean, that is x bar given 3.92, and what is given here, standard deviation s given 0.61. So everything is ready. So what is the formula to find? Here what is given, 95% fiducial limit, that means confidence limit. How to find x bar? Plus or minus s by root n into t 0.05. This is for when student t distribution given, then the confidence limit we can, probable limit or confidence limit we can find with the help of this. So everything is ready, just you need to replace it and find the value. We will get, if you add 3.92 plus 0.41 you will get 3.51, and if you take the difference 3.92 minus 0.41 you will get, if you take the difference 3.51 and if you add this one 3.92 plus 0.41 we will get 4.33. So thus 95% confidence limit for mu are what? One is 3.51, another one is 4.33. Okay. Now two horses A and B were tested. Again here same case. There are two different data. So formula you have to take x bar minus y bar, or here A bar minus B, like that, to run a particular race with the following results. Horse A they have given like this, horse B given like this. Test whether you can discriminate between the two horses. This is very important sum. See here, first let the variable x and y respectively corresponding to A and B horses. What is x bar? That is summation x by n1. And what is y bar? Summation y by n2. That is nothing but what? X bar is what? Add this 28 plus 30 plus 32 plus 33 plus 33 plus 29 plus 34 divided by what is 7. Similarly here for y bar is 29 plus 30 plus 30 plus 24 plus 27 plus 29 divided by how much? 6. Do that and find the value of x bar and y bar. You will get 31.3 and here 28.2. Now we need to find what? S square. What is S square? S square is nothing but what? 1 by n1 plus n2 minus 2 into what? S1 square plus S2 square. But how to find S1 square? S1 square is nothing but summation x minus x bar whole square. That is you will get 31.43. And what is S2 square? Summation y minus y bar whole square. How to find s minus x bar whole square? X is already ready here. See, 28 minus what? X bar 31.3 whole square plus. Similarly, you have to compute it for each and every term. That is 30 minus 31.3 whole square, like that. Each and every one you calculate, you will get like this. So we got s1 square and s2 square. Just replace here back. So 1 by n1. n1 is nothing but how much? 7, right? n2 is nothing but 6. So 7 plus 6 minus 2, that is 11. So simplify s1 square is 31.43 plus here 26.84. Simplify, you will get 5.2973. But what is S? Square root of S square, right? That is 2.3016. Now compute t value. What is t, student? T distribution? X bar minus y bar divided by s into root n 1 by n1 plus 1 by n2. It should be 1 by n1. Everything is ready. X bar we have already obtained 31.3 and y bar is 28.2 and s is nothing but what? Here, square root of variance, that is standard deviation. We got 2.3016 and 1 by n 1 by 7 plus 1 by n2. It should be n1. Now if you simplify you will get 2.42, but actually what they have given t 0.05 is 2.2 and t 0.02 is 2.76. So we have to check whether it exceeds the limit for both or it does not exceed the limit. Say here for 5% level of significance, actual maximum limit is 2.2, but here we are getting 2.42. That means obviously it exceeds the limit of this. But in the case of 2% level of significance, we are getting 2.72, but here 2.42. So 2.42 is obviously less than 2.72. So therefore the discrimination between the horses is significant at 5% level, but not at 2% level of significance, right? Now, again here, a group of 10 boys fed on a diet A and another group of 8 boys fed on a different diet B for a period of 6 months recorded the following increase in weights. Now diet A they have given like this, diet B given. Test whether diets A and B differ significantly regarding their effect on increase in weight. Now first find x bar, same here, summation x by n1. So what we will get here? 5 plus 6 plus 8 plus 1 plus like this. 12 plus 4 plus 3 plus 9 plus 6 plus 10 divided by n1 means 10. So 64 by 10 means 6.4. Similarly find y bar, 2 plus 3 plus 6 plus 8 plus 10 plus 1 plus 2 plus 8 divided by n2. So what you will get here? 40 by 8 will get 5. So what is x here? S1 square and s2 square you have to check, that is summation x minus x bar whole square. You will get here 102.4. That is how to check. X is nothing but this one, x bar is nothing but this one. So 5 minus 6.4 whole square plus 6 minus 6.4 whole square plus 8 minus 6. Like this. So if you add you will get 102.4. Similarly for this y minus y bar you will get 82. So what we will get at the end t value here? Here s square how to find? That is nothing but 1 by n1 plus n2 minus 2 into this. Summation x minus x bar whole square plus summation y minus y bar whole square. You will get 11.525, right? But what is the s? Square root of s square, that is 3.395. What is t, student? T distribution x bar minus y bar divided by s into root 1 by n1 plus 1 by n2. Simplify here, 1.4 divided by 3.395 into root 1 by 10 plus root 1 by plus 1 by 8. You will get here 0.86935 or a 0.86935. It is near to 0.87. But what is actual value of t 0.05? That is for 16 degrees of freedom its value is 2.12 and for its value is here 0.87 we are getting now, and which is less than the given table obviously. See, 0.87 is less than 2.12, but for 16 degrees of freedom it is obviously it is accepted, right? Thus we conclude that the two diets do not differ significantly regarding their effect on increase in weight. Okay, now here student t distribution completed.